I have a problem. The 3D printer keeps stopping. Well, it doesn't keep stopping. The fibre keeps stopping coming out. This one managed to get to, I think it was 1.4mm of print and then stopped. I noticed that it was all still moving because I'd left it to get on with it, but the printing head was sort of about 25mm off this and no filament was coming out, so that was ruined. I tried it again, pushed a bit of the fibre through, you know, poked the fibre in this bit so it went through the pipe, down through the print head where the little heater is, and extruded it out the bottom, and there's nothing stopping it coming out. Thought, well, that's okay then. Tried another print and it got to this stage, and this is quite interesting because did a little bit more there, probably about 2.5mm, but you can see how, especially if I zoom in a little bit, there you can see how it prints a solid layer. I don't know where my finger's gone now. Prints a solid layer at the back on the bed of the machine, then starts building it up, filling it with these squares. I think it's 15% of the inside is set to fill up, so it prints these squares, and then when it's time to stop filling them and put another side on, if you like, top edge, top side, don't know, that it starts printing all these little fibres across to slowly bridge the gap, and then it fills it up and prints the next solid layer on top of that. Interesting, but not very much use when you realise that the print head has left that down there and is sort of, I don't know, about 25mm up. And whenever I looked and checked at the temperature display, it was always at the set 215 degrees C, which means that the heater in here is working perfectly, and the sensor in here, the temperature sensor, is working perfectly. So, cut a long story short, I started thinking, well, the only other thing it can be is the bit that actually feeds it in, that squeezes it, and it has a spring here, and the fibre goes between these two rollers. If I can, rollers, sounds very posh. Come on, focus. So the fibre comes through a hole here, squeezes between these pinch rollers, and this one's on top, this driven by the motor underneath, and then gets fed through the pipe all round the houses into the print head, and it's forced back by the spring that's here. And I noticed that this pinch roller seemed to be a little bit wibbly wobbly, so further investigation, and of course that's now done itself back up, revealed the back of this is all cracked. So this is the tension arm or whatever. You can see there's a big split through it. The plastic's cracked around that brass insert, and that means that this is all wibbly wobbly, which means that the tension on the fibre that drives it through was just failing on a regular basis. There's two options here. One is to order a new one on Amazon or something rather, online, or two, the far more complicated option, is to make a new one here. Which to choose? Now then, as I see it, the important parts are, let's just draw it roughly. Right, I've got the drawings done, high quality as you can see, with all the measurements that I think are really important, so that I can, it just makes it easier to scribble them on paper and then transfer them. Well, I'm not going to dimension the drawings I'm going to do on CAD, I'm just going to do them from these dimensions. Here's the offending item. I'll zoom in. There. So there's the little Allen screw that holds it in place. There's the bearing, the tensioner bearing. There's the little brass insert. And I assume that they've pressed it in afterwards, and the hole that it went in was just too small. And I bet this is a really common problem, because for it to fail like this, and I've had it since what, August I think, and I have used it a lot, but I bet you that these Creality 3D printer Ender 3 things, I bet they all go there, the tensioners. I'm also thinking about whether to replace this with a couple of bearings, because that's got to take all the force that's been exerted by this spring that sits here. it's a shame I've got to do the work on the CAD software on the other modern Windows 10 computer, copy it onto a pen drive simply so that I can bring it through here and use the computer that's connected to the laser cutter, which is a lovely old XP computer, so nice, and then use this one to control the laser cutter. How ridiculous. I can't connect this to the computer, the other one, or wire it up through the internet or whatever, simply because Microsoft have stopped supporting it and producing the security patches. What a shame. Never mind. Now I've cut out the 3mm bits, I'll go backwards and delete those. Let's delete something. Oh well. So because this is 5mm thick, and because the company who sells these laser cutters recommends not to exceed the 40% power on the 60-watt tube, you need to cut it, slow it down so it produces more heat and cuts through thicker plastic. I could run it at 100%, but having read stuff about laser cutters and things, it sounds like if you really push it to the limit, the laser tubes don't last very long, and the lenses and the mirrors and everything else, they all wear out pretty quickly. So I'm happy to stick with what it suggests, the 40%. It means it takes slightly longer, but if the laser cutter keeps working, then it really doesn't matter. There we are. So there's the 5mm bit with the two little notches on to show me where to drill the holes. So let's glue them all together. Right, a tripod I hear you cry in delight. At last. Stable filming. So here are the bits. Here are the two 3mm pieces, and here's the 5mm thick one, which adds up to 11, which should be fine. What I'm going to do is I'm going to glue, oh focus, I'm going to glue that and that together. What I've found is, using these lovely V-blocks, which I've mentioned before, if you slot one bit in there, you can line it up quite easily. Although, even though I've been using super glue for years, it still panics me a bit when it sort of starts setting. How long have I got? Is it going to set? Have I wasted all this time? But look, if those are like that, that is definitely lined up. So what I'm going to do, I'm going to start shaking now. I'm nervous of super glue. Anyway, let's put some of the aforementioned, oh, it's got a blob of it, don't want that. Alright, let's get some, run it along, make sure we've got little, I don't want too much, otherwise it's going to stick to the V-blocks. Turn it over, nerves, squeeze everything together quick. I think that's okay. Oh, I think that's okay. Beautiful plastic things. Now the good thing about super glue is, if you see at this end, it hasn't quite, let me hold it so it focuses, hasn't quite gone in. So what you can do, because of capillary action, if you just dab a little bit along the edge, that will then run in as it has done, and then you can just wipe it off. Just be aware that it's an exothermal reaction when super glue sets, and it's fine, you don't notice it in small amounts, but if you put a load on a tissue, it really does get very hot. I don't know whether it would ever get hot enough to burst into flames, but I remember talking to someone and they dripped a load on their trousers by accident while they were working, and they weren't aware of it other than they got burnt on their leg. So that's just something to be aware of. Now that's lovely, and because that's fabulous super glue, that is going to be set very quickly. While it is, just to make sure it is, I am going to search for little bearings to go in here. Let's see what we've got. Ooh, this looks like a small tube. Ooh, a small. Oh, look at these. They are just incredible. I mean, I've seen videos on how they manufacture them, but nonetheless, it is a miracle. These, oh, look at that. Zoom in again, especially with these ones. So these little bearings have got a 3mm centre hole, which is fine for this thread. I need to use this bolt or threaded screw or whatever, machine screw, because it needs to go in and hold the motor on as part of the whole assembly. But that's brilliant, and these little bearings are so small that I can happily drill out a little hole in the top and bottom. Oh, you've got to, haven't you? You really have got to. Right, that's lovely. I'm going to do that, and I'm going to have a think about other stuff. Funnily enough, I got these little little bearings for the reciprocating chronometer clock, which I am still developing, because it only uses gravity and a snail cam to translate rotary motion into the reciprocating motion to tell the time. The bearings had to be as small as possible, but to reduce friction of this arm against the snail cam. You might be able to see better with this one actually, because this is a later version I didn't bother painting, so you can see this lever drops down, going into rotary motion, but this follows this snail cam, so it slowly moves the pointer all the way up over 12 hours and then drops back. The reason I haven't finished these yet is because I cannot reliably get the AM/PM sign working. Everything, logic tells me to forget about it, keep it simple, but I haven't come up with the idea. It's got a very complicated shaped cam that goes round and pushes a little arm backwards and forwards to reveal PM, AM, PM, AM, so forth. But it doesn't work 100% reliably, so it's something I still need to sort out. The little bearings are 6mm outside diameter, so that's fine, and I'm going to have to use them anyway because I have lost the little plastic insert. It has gone the way of many things and fallen onto the carpet of invisibility. I do apologise for my slippers, but you know, needs must when the devil rides. I've got a 6mm drill bit here. I've got the little bit of plastic thing. I'm going to counter drill a little hole at the top and the bottom that is about 2.5mm deep. Really inaccurate. You've got a hole at the laser cut beforehand. It always lines up perfectly. I'm just going to try to get into the boom, so to speak. Very important then to hold it very firmly, otherwise the drill will slowly smash it up and go around and smash it. RS Pro. Must be good. Definitely not an own brand. Right, so there's the 3.3mm drill bit. So I'm going to now endeavour, without getting my fingers in the way, if I put the camera the other side of the drill, then so I turn it up and down, wind it up and down, it hits the camera. Note to self, remember to loosen. In order to set this, by the way, where are we? Here we are. It's got a screw thread with 2 nuts, and it's really annoying. I keep meaning to get, you can get one of these little adjusters where they're spring loaded and you push them and they just slide up and down and lock into place really easily rather than having to do this, but I haven't got around to it. Right, let's give that another go. This damn woodworm, they're huge. Right. Lovely. There we are. Okay, I have got the M4 tap in the drill, which is probably pretty unwise because you can, if it's sort of something slightly stronger, you can use a tap wrench. I'm just going to spray a little bit of the isopropyl alcohol because it helps to stop it from clogging up. Now I'm going to try and do this and it's going the right way, and I'm not looking at what I'm doing because I'm trying to video it, and in fact, yeah, let's do it this way. I think that might be easier. Right, line it up, try and get it to go in vertically, and then as with all tapping, in a bit, out a bit, shake it all about. Just thinking about how to support the end of the spring against here to stop it slipping off. I've drilled a 3mm hole and found that, ooh, it's lucky it didn't fly off, and found that the head of an M3 screw just perfectly supports the end of this spring, so I'm just going to glue it in. It's not even worth tapping. Luckily I found I had some of this brass tube that's internal diameter is 2mm, which was what the guide in the original tensioning thing was. So the fibre, printing fibre, of which this is a part, goes through it easily. I was thinking, well, how can I can't make a flange on the end really. There's not really enough to machine, and I remembered I'd bought these ages ago. Very small pipe bending springs. If you bend a pipe without anything, it just crumples because there's nothing to keep the structure together, and everything just crumples and folds, and it's useless. And I'm not going to show you that because I like this brass tube. If you put a spring on it first, such as like this, then you can bend it, and the spring stops it from crumpling. It keeps its form, its circular form. Bend it a little bit more. There we are. And that is lovely, because now the fibre will be guided beautifully gently round the corner and past the pinch rollers and things. So I'll cut that off, drill a 3mm hole, I think. If memory serves, let's have a look. Yeah, there we are, 3mm hole, and get that glued in as well. Right. So I'll put this in the vise, the little brass pipe. I don't want it to be that long. And I'm reduced to using a large hacksaw. Did have a small hacksaw. Wretched own brands. I think this was B&Q. I was out somewhere and needed a hacksaw like you do. I just couldn't believe how awful the quality. Own brands always start off, I remember when they first started, and you'd think, wow, that's so cheap and such good quality. And then inevitably, gradually they replace all the proper things with own brands that are rubbish, absolute rubbish. So, big hacksaw. I've learnt numerous times taking a shortcut and not bothering to clamp it. Right, no catastrophes. And if I get it focused, there we are. So there's the hole through the centre, and that hopefully will deliver the fibre in just the right place to line up with the edge of the pinch roller. So I've threaded the hole at the top and bottom in one go. They will, I know, line up. The thread will line up. So if we put that through, it also allows me to tighten it, because relatively speaking, they have to stay in line. So that's fine, that's nice. And that now clears that, so that's lovely. Yay! Right. Okay, that's now under tension. Oops. Don't know how long it'll last. There's an awful lot of tension on there, and it's trying to open up this bit. Should really be metal. Handheld, so much easier. So there's the fibre coming down. It goes through that little brass tube, the guide, and then you can see it's sitting between the pinch roller and the splined gear on top of the motor. It comes through here, around here, down into the print head, which is currently heating up to 215 degrees C, and then there's the little nozzle at the end where it's going to be forced out of, hopefully reliably. The nozzle's reached 215 degrees centigrade, and I've shoved a load more fibre in. You can see it's just come out underneath, so I'll clear that away, just pull that off. So this is the improved, so I'm going to click that. And so far that's turning, and while that's turning, the gear with the pinch roller is still turning, and so far, and it's still very early days, but it seems to be printing properly. There's consistent thickness of plastic coming out, whereas before, even by this stage, it was all over the place. It's half an hour later and lunch later, and I'm very pleased to say it's still working. It's printing really nice and evenly like it used to do. That's turning still, but most importantly the pinch wheel bearing is turning as well. You can just see little marks on it going around. So I'll leave that going, and hopefully it will complete this gauge. Ta-da! It works, it works, oh fantastic. This is 3 hours 50 minutes later, but it is complete. It hasn't stopped, so that's very exciting. A lovely new tensioning system. The Rolls Royce of tensioning systems, if I may make so bold. Excellent. And an executive decision. I'm going to finish these next 11 kits tomorrow, which is very enjoyable, getting them all cut out and all the bits made and then everything assembled and collected and counted in and out, which is brilliant. I've got another kit someone's ordered ready assembled, so I'm in the process of making that. And I think, after the failure of this wig for Florence's sister, larger sister Victoria, I am going to forget about hair. It hasn't bothered me forgetting about hair for the last 35-40 years. I'm just going to design it and start working on it. I might even think about printing the hair, so 3D printing it with black gloss fibre. I mean, that would look brilliant. Also, it would mean that I could have the whole of the back of the head open to get to the works, and the hair could just clip or screw on. So it's something I need to look at. Someone very kindly suggested that if I was going to make Florence bigger, Victoria bigger, Florence has got not that many facets. Her head is made up of not that many polygons or whatever they're called, so you can see them catching the light. And if I blow her up at all, keeping that effect, it's really going to be quite obvious. She's going to look like Crichton off Red Dwarf, which I don't really want. So I think I might have to look into some slightly more complex and involved 3D design software. So watch this space, it's exciting. I can't wait to get started. Thanks very much for watching.